if the loading impedance isn't precise and is just set to high or low like this, rather than a phono stage where the loading impedance is imprecise and just set to high or low. I think.
Hey guys, welcome back for another video. This is my second interview that I was able to get at the 2025 New York Audio Show. This is with the founder and designer of the new Titan turntable from Titan Acoustics, Seok Lee. Now you'll notice I have his face blurred, and that's purely for completely non-related professional reasons. Back in Korea, it has nothing to do with any of the content in the video. So let's jump right into the interview where I asked him, how does the cartridge choice come into play when designing the turntable?
It's about what kind of sound you aim for, right? So, when I was developing it, my main focus was that traditionally, analog audiophiles tend to buy various cartridges and enjoy experiencing the unique characteristics of each one, and they consider that important. But if the turntable's character is too strong, it can dilute the performance of the cartridge. So in order to let the cartridge perform at its best, as I mentioned earlier, our product allows you to freely adjust the VTA and effective mass. Plus, with high-speed stability and excellent vibration control, our goal is to deliver the pure, original performance of the cartridge, using the record as it is, conveying the sound information stored in the record neutrally, without any added distortion. That way, users can more easily tune their system to their liking using the amplifier, speaker system, and cables they already have, so the source device should be neutral. Instead, it needs to deliver as much information as possible to the amplifier stage without any distortion.
So with all the various material choices for the tone arm, the platter, the chassis, etc., what are some of the sonic characteristics of the different options, and why did you choose the combination that you have here?
It needs to be resistant to vibrations from outside and also to resonance. That's why we chose aluminum, because its high mass and favorable resonance properties make it advantageous. Also, when the mass is high, you get some benefits from mass damping. That's how it's designed, but the downside of metal is that, depending on its shape, there are resonance points. So, to move those resonance points as far away as possible from the audible range, we used FEM on the lower part, and machined the shape accordingly. By doing this, we can effectively move the resonance point away from the audible frequency range. The same goes for the platter. It needs to be massive and free from resonance, so we stacked carbon fiber with aluminium, which allows us to increase the weight and suppress resonance as much as possible. As for the tone arm, it needs to have excellent stiffness and rigidity. That way it can track without distortion, so our tube is made from real carbon fiber, and the body is made from aluminium and duralumin.
So how did you get into the world of high-end turntables, and explain the background on the name you chose?
I was an analog audiophile who enjoyed listening to music in analog, and during that process, since my major was mechanical engineering, I was an audiophile who, unlike others, frequently changed and used different turntables within my audio system. Usually, because amplifiers or speakers change the tone the most, people tend to swap out their amps or speakers, but I kept using about 10 different turntables. There were things I found lacking with each one, so vintage turntables from the past were reliable in terms of function, but now, because time has passed, it's a bit disappointing that their durability and performance aren't what they used to be when they were first developed. And compared to vintage turntables, modern ones, in terms of functionality, lack reliability. Turntables that actually have the features I really want are so expensive that it's hard to justify buying one. So I started thinking, maybe I should try making one myself. Plus, my background is in mechanical engineering, and I've worked in that field for over 15 years, so I thought I could apply the technical elements needed for a turntable like making the platter spin properly and designing and manufacturing the tone arm with precision. I have the skills to design and manufacture a tone arm that can achieve perfect tracking, and since I've spent quite a long time working in manufacturing at this company, I also have a pretty solid network in the production field. By making use of these things, I thought I could create a proper product. I wanted to make something that delivers solid performance, but is also reasonably priced, and that's how I ended up making it. The name Titan. Actually, I spent a lot of time thinking about the company name, and after reading the book Tools of Titans, I saw that Titan refers to something or someone that stands at the very top of its field. You can think of it as meaning that we aim to be the best in this field, rather than just being a giant.
What are the most critical tolerances of a high-end turntable, and how are you achieving those in your manufacturing?
As you mentioned, high-end turntables are essentially machines, so there are rotating parts and swinging motions. The tone arm moves, so mechanical precision is extremely important. First of all, when we talk about the level of mechanical precision in technical terms, there's something called the International Tolerance Standard. The design aims for grade 2 as specified there, and applying this to the spindle, or the bearing connection shaft of the tone arm, is extremely important for rotational precision and tracking ability. So, the design specifications are set to target IT grade 2G, and when it actually comes to manufacturing, it's necessary to optimize the machining process depending on the material and the position of the component being used. So, with certain materials, if you use standard machining, you can't achieve the required precision. That's why we first do a primary machining, and then follow up with grinding to meet the precision requirements. So in those cases, there's a significant difference in the level of tolerance, the speed precision when the part is installed in the turntable, and even the sound quality, depending on whether grinding was done or not. That's why, for each part, it's important to set a high level of tolerance grade in the design, and to determine and apply the appropriate machining method for each part. Also, during the machining process, how you clamp certain areas of a part, and at what speed you machine them, all of these factors are important. So, for those processes, we record and manage all the machining conditions. This later helps us improve the product and raise the tolerance level.
And can you detail the significance of what International Tolerance Grade IT2 means?
Depending on the industry, there are precision grades, and generally, there are standard precision grades that are applied. But usually, in the automotive industry, grades 5 or 6 are the design targets, and grades 2 or 3 are almost aerospace level. These are not grades you can achieve in mass-produced products. You would have to machine each product individually and check every dimension one by one. As I mentioned earlier, you also have to consider the clamping points in the process, the machining speed, and the feed rate. Only when the machining speed or the clamping points are optimized can you achieve that grade. For high-end turntables, to meet the performance requirements I mentioned earlier, you need to reach about grade 2 machining quality.
So I think it's really interesting to talk to someone that is both a hardcore engineering background but into turntables, which I kind of view as more of an emotional field. How do you determine that a design is finished? Like how much development time was into this product, and what made you say this is now ready for production?
The development period was about 5 years. It took roughly 5 full years. And as you mentioned, with audio equipment, even if we achieve a perfect design using C80 software, that doesn't necessarily mean it will produce great sound or track properly. After the design stage, the tolerance levels I mentioned earlier, and the choice of materials, all of these factors later affect tracking performance and sound quality. So rather than just the initial design and concept, a lot of time was actually spent fine-tuning those angles and calibrating the key points, which is why it ended up taking about 5 years. And since the finished quality of the audio itself is also important, we focused on achieving a uniform color and a clean, precise finish on the plinth, putting a lot of effort into ensuring high-quality craftsmanship. The total development period ended up being about 5 years, so you can say it took around 5 years in total.
You have a specific cartridge that you're using here at the show. Is that more of something that is to be paired with your turntable or a personal choice?
That's right. As I mentioned earlier, our product places a lot of importance on cartridge compatibility. That's why, instead of saying the cartridge we brought today is well matched with our turntable, it's designed for most cartridges. We've installed the Ortofon Verismo cartridge on our turntable, but it's not about synergy with our turntable, it's more accurate to say it reflects my personal preference. My preference is for a cartridge that can extract and track as much information as possible from the record and transmit it as an electrical signal. That's the type I like best. The Verismo, compared to other MC cartridges, especially modern MC cartridges, has a certain musical quality to it. So, it delivers a lot of information, but also has musicality. That's why I chose the Verismo. As for cartridges, the Titan Acoustic Stone Table is highly compatible, so it doesn't really discriminate much. Also, whether you use an MC or MM cartridge, the way you select the ground can differ. Our product has a feature at the back that allows you to connect or disconnect the ground depending on whether you're using an MC or MM cartridge, so you're not particularly restricted in your choice of cartridge. You do not have to worry about that, because everything has been carefully planned and managed to make sure there are no problems.
So, the concept of a turntable is now over 100 years old, and we've seen major advancements and minor improvements over the years. What are some of the changes and improvements that your design has over existing?
If you look at vintage turntables, for example in Japan, they use direct drive turntables. They manufactured these products and swept the world market, especially as they dominated the market for professional broadcast use. And some European brands, by applying a lot of new technologies in tracking ability through precise tone arm design, have produced many tone arms that are still recognized as masterpieces to this day. So, there were major turning points in the history of each turntable. There have been technologies that marked major turning points in the history of each turntable, but when I think about what characterizes recent turntables, I believe it's the materials. The concept that turntables have now, the swing. The concept of tracking in the cartridge making an electrical signal hasn't changed. It's basically the same as when it first appeared. The platter spins by belt or direct drive. Some brands use magnetic drive, but most use traditional ways. These methods haven't changed much from the technology of 50 years ago to now. But I think the biggest changes have been in the materials. As I mentioned earlier, while the basic concepts have mostly stayed the same, the spindle needs to be made of a material that can absorb small amounts of friction and vibration. Carbon has been widely used in audio equipment for about 30 years now, but when it comes to the tone arm, it's actually a very suitable material. And materials like sorbothane, which absorb and dampen vibrations, used to be found only in aerospace applications, but now that they've been introduced to audio and applied to turntables, they deliver excellent performance. Also, polymer materials, which used to be dismissed as just plastic, are now recognized as very good for achieving damping and controlling resonance. The Titan acoustic turntable also has polymer in its feet, and some parts like the hinges or the VTA adjustment section use polymer materials as well. So, in terms of materials, they tune and calibrate the product by applying the most suitable material to each component.
What type of drive system are you using, and what are the sonic characteristics of the different types, and why did you choose what you did?
As for me, I've used a lot of turntables, and I prefer the belt drive system. That's why I also developed my product with a belt drive system. We use a synchronous motor to drive the platter with a bell. With a synchronous motor, the rotational precision is determined by the frequency supplied to the motor. So, in our product, the external power supply generates an accurate sine wave for the synchronous motor. In that process, we use an OCXO to process the sine wave before sending it to the motor. This allows the synchronous motor to rotate the platter at a precise speed. And as for the belt system, We used an O-ring cross-section belt rather than a flat belt to help minimize vibration transmission. Additionally, the motor is isolated from the plinth using sorbothane, which helps to suppress vibration transmission as much as possible. Even if the motor generates an accurate sine wave, if friction in the platter spindle is high, wow and flutter or rotational precision will decrease. So, for our product, the spindle housing is precisely machined from brass, and the spindle itself is made of stainless steel. The vertical support that bears the platter's load is designed to minimize friction by using a ceramic ball.
What are a few of your favorite records and tracks specifically that you use for setup that viewers at home can then listen to themselves, and what specifically are you listening for?
When I am setting up, I often find myself listening to Cannonball Adderley's beautiful piece, Autumn Rivers. When I listen to records that have been pressed in stereo, I enjoy listening to 45 RPM records, which are small vinyl discs that play at 45 revolutions per minute. When I place one of these records on my turntable and gently lower the needle, I hear the familiar crackle and pop that signals the start of the music. The sound that comes from these records has a warm, rich quality that I find deeply satisfying, and it often brings back memories of earlier times. Each 45 RPM record usually features just one song on each side, making it easy to focus on individual tracks and appreciate the unique artistry of each performance. Listening to these records is a special experience that connects me to the history and tradition of recorded music. I check for details like the sound of air leaking from the saxophone reed and the creaking noise from the hinge when the kick drum is pressed. Those kinds of details really come alive, so I pay attention to them. And as for the bass, I check if the plucking is clear and dense. That's why I use that record.
What are the important specifications of a phono preamp, and what's your preference in pairing with your turntable?
In my opinion, the most important aspect of a phono amp is, first of all, noise. I think noise is the most important factor. Usually, an MC cartridge is 0.2 millimeters. The phono stage amplifies the low voltage signal for the preamp. If noise is amplified too, it reduces detail, depth, and stereo separation in the sound. The focus also tends to become often blurred, so I believe the most important thing is the ability to effectively amplify the signal while carefully suppressing noise. Secondly, it's about ensuring the proper matching of the overall efficiency of signal transmission for each individual cartridge. The focus also becomes blurred, so I believe the first important aspect is the ability to amplify the signal while suppressing noise. Secondly, in order to match the efficiency of signal transmission for each cartridge, you need to set the loading impedance on the phono stage. If the loading impedance isn't precise and is just set to high or low like this, rather than a phono stage where the loading impedance is imprecise and just set to high or low, I think it's essential to have a function that allows you to adjust or set the loading impedance precisely to a certain value yourself. Those two things are, when choosing a phono amp, the most important.
So I understand the TX100 here at the show is your latest prototype, and you are currently seeking US distributions. Do you have a preferred contact that anyone can get in touch with you with?
Yes, our company has a website. The prototype production is now complete, and we finished the certification tests for Korea, Europe, and the US. We expect to have all certifications finalized by the end of this year.
Thank you once again for being with us today.